Screen visible?
Yes, ma'am.
Yes, ma'am.
Okay, so in previous session we started casting. Today I will quickly tell you about the casting techniques and we will solve the questions from gate of castings. So, last session only we have seen that it is divided into two parts, expendable modes and permanent modes. Expendable mode, your mold will be temporary, and in permanent mode, your mold will be permanent, like metallic mold. So, expendable, we have sand, shell, investment, full molding, and CO2 molding. In permanent, we have centrifugal casting, die casting, slush casting, and squeeze casting. So, let's start with the sand molding. So, how this diagram is showing you the mechanism of sand molding. It is simple. Simply, they are using sand to form your mold, and if you need some kind of holes, then you will use a core, which is known as sand core. And again, we have studied about cope drag and gating design for the sand molding process itself. So this is a very simple kind of casting process. It has application which is air compressor pistons, bearings, blowers, impellers and brushing. So this kind of casting may have some defects also. Then next move on to shell molding. So what we do in shell molding? Firstly, suppose this kind of product you want in the screen, this kind of product you want, which is inside hollow. So what you do, firstly, you will make one pattern. You will heat that pattern, and this you will reverse it. So the sand will stick on this pattern. Then what will you do? You will make this shell. From that pattern, you will make this shell, this kind of, and you will do it for one more pattern. So this kind of shape will be manufactured. Then directly you will pour the metal into that, and this kind of hollow, what we say manufacturing you can make by shell molding. So what are the uses? The uses is cylinder blocks, rocker arms, and some wall parts of refrigerator. Then investment casting. Investment casting is very important. So in the diagram, usually it is useful for medical dentures or dentures. So suppose this is what? This is a kind of teeth you can say. So how we make? Firstly, what we will make in investment casting? Firstly, what we will do? We will make one this kind of die, rubber die. This die. Then we will make a pattern of wax with the help of this die. Okay. Then after that, that wax pattern with the similar wax patterns, we will make a gating design. Here, what things are there? Feeding system is there. These are your patterns. These all are made of wax. Then after making this assembly, we will pour that we will pour that into some ceramic slurry. Okay, this kind of slurry. Then after pouring that, we will heat it in some oven. So this kind of assembly will form, in which these are your patterns which are required, and this is made of what? Ceramic slurry. Then what we will do? We will heat it or de-wax it. We will heat it, then your wax will be melt and it will be removed. Then this kind of mold will be ready by ceramic. Then what you will do? You will pour the molten metal into that, and then you will break the ceramic shell. After breaking ceramic shell, this kind of casting will form, and then you will cut the required piece for yourself. So this is the investment casting. So it is very important to understand what is the procedure is going on and what are the applications of investment casting. So uh, basically in medical field it is being used a lot. Apart from that, gas turbine blades and jet engine parts also being made by investment casting. Then full molding, or it is also known as evaporative pattern. So what is happening here? See, in different kind of casting, what is the difference? First is the molding difference and pattern material. Molding material different and pattern material different. In firstly, what we are using in sand molding, we are using green sand only. Okay, this is made of sand, green sand. In shell molding, what we are doing? Firstly, we are making a shell for the pattern with the help of sand only. Here, what we are doing? We are firstly our pattern will be made of wax. Then we are making a ceramic slurry. In full molding, your pattern will be made of polystyrene foam or any of these material. This is also important. You should understand what is full molding. One pattern will be cut from plastics or polystyrene, foam, PVC or thermocol material. This kind of material. Then that pattern will set into the frame, whatever the required frame, whatever the manufacturing you want to cast, you will set that into the frame. Then you will displace the pattern with the molten metal. That means when you will pour the your molten metal, your pattern will be evaporated. Okay, after that your casting will form, and like this kind of can or something, motor casings fitting tooling can be made by full molding. Then centrifugal casting. Now this is what? This is permanent mold kind of casting. So what happens in centrifugal casting? There will uh, there will be your mold which will be continuously rotating. Okay, there will be two rollers, top roller and bottom roller, and this will continuously, those because of those roller will be movable, so your mold will be continuously moving. So when we were pouring the metal into your mold, due to centrifugal effect, it will thrown out to the out from the center. So this is how hollow cylindrical pipes can be made by centrifugal casting. Mostly centrifugal casting is used to make the hollow cylindrical pipes. These are some other applications. So mostly in exam they will give you match the following, in which they will give you 4 5 casting techniques, and then they will give you 4 5 products, and they will ask you that from which technique which product is being made. So you have to think that what kind of product can be made with what casting, and for that you should know, just a second, you should know about the process and applications. Next is die casting. Yes.
And can you kindly explain the applications like how can we identify shell molded products?
See, firstly, whatever the broad it is written, you should remember that, right? Here you can say uh, whatever the hollow kind of thing also make from the shell molding, but you can say it will be not that strong. Okay, because what we are, how we are making, firstly we are making first shell, then second shell, then we are filling it. So it is not going to be very strong. Okay, so this kind of arms and all can be made by shell molding. But for suppose you are making very big and big diameter pipes, which are going to be used for some structural applications, so that you can know that will not be able to made by shell casting. For that you might have used centrifugal casting or some other casting techniques. So that's how you can think of by the products. It is not easy, but somehow if you don't remember, you can make a guess like what kind of casting process is being used to make that product. Then the die casting. Die casting is the easiest. There will be one die. Uh, this molten metal will be filled in the die. Then you will open the die and you will take out your casting. Like from here, there's some screw management will be there. You can remove the screw and you can open the die and your casting will be out of the die. So what are the types for die casting? First is gravity, then hot chamber. These things are in notes. So you should go through that. I'm just telling little brief. In gravity, in gravity, what happened? Your material will be poured in the die due to gravity. Okay, in the gravity die casting. In hot chamber, what is going on? In hot chamber, your furnace will also be built with the die. In cold chamber, your furnace will be outside of the die. Okay, these are two differences between hot chamber and cold chamber die. Then the applications of die casting is also mentioned here. Then slush casting. Okay, this is how what is going on in this. Suppose this kind of pattern you have and you want to make some hollow thin casting, very hollow and very thin casting you want to make. So what you do, suppose you want to, there is some glass and you want to paint that glass. So what you do, you pour the paint into the glass, then you remove the paint and automatically your glass will be painted. Same way slush casting process is, like suppose this is your cavity, you're filling it with the molten metal, then immediately you're removing the molten metal. Then whatever, then you're heating it, then cooling it, whatever the left is your hollow casting. That is the process of slush casting. So here also you can see what are the application. Very thin castings, hollow thin castings, hollow statues, toys. These kind of thing can be made by slush casting. Then the squeeze casting. Squeeze casting is explainable by its diagram only. What will be going on here? Molten metal will be there. Then some upper die will be there. You have to design your die. What kind of shape do you want for your casting? Then you will press the die. Your metal will be squeezed up in between the gap of your upper die and bottom die, and then you'll remove your upper die and then you'll cool it down and you can remove your casting. So there is only less application for that, but you should remember because this is important. What can you make? If they are mentioning aluminum anywhere, so you directly take the squeeze casting. Okay, so brake shoe made of aluminum can be made by squeeze casting. Then bush, that could also be suppose any this kind of aluminum, copper, brass branch in there, and you are not you don't know, you are not sure about the application. So if squeeze casting is there, just take the squeeze casting, because for this kind of metal these castings are used, these casting types are useful. Then the difference.
Excuse me.
Yes.
What is the difference between hot chamber and cold chamber?
Okay, in hot chamber your furnace will be with the die itself. Suppose this is your die and you are pressing your molten metal into the die. This is your piston. So your furnace will be somewhere here only. So from there directly your from furnace directly you are pressurizing your molten metal into the die. In cold chamber your furnace will be somewhere apart from your die. You are getting your molten metal here from, and then you are pouring it into the die. That is cold chamber. Furnace is not connected with the die in the cold chamber. Okay.
Can we make complex shape with this like casting?
With the die casting, yeah, we can make that, because in what we are doing, we are designing the die only. So die you can make any complex shape and then you can fill it. Mostly complex shape can be made by die casting only.
Okay.
In gravity, plungers act because of gravitational force. Na?
Sorry.
What happens in gravity directing?
In gravity, your molten metal is being poured into the casting because of gravity only. Like in the notes that I have shared, there will be diagram for gravity, die casting, hot chamber and cold chamber. We refer that diagram, it will be clear.
Okay.
Okay, in hot chamber and cold chamber, we will use plunger to fill the metal. Okay, in
Okay.
gravity, we are not going to use any plunger or piston. Then defects. Firstly, these four kind of defects are there. This is also in your notes. You for like explanation, you go through it. These are gas defects. So because of gas is trapped in your casting, if the hole is inside, some hole is or some hole is formed inside the is formed inside the your casting, then it is called as blowholes. It is if it is on surface, it is called as open holes. Then blister, some thin layer of metal is formed on the surface of your of your casting, that is called blister. Then this kind of what you say hollow blow is formed on the surface due to these are gas effects only due to gas trapping, that is called scar. Then pinhole porosity, it is because of hydrogen gas. If your hydrogen gas is trapped inside your casting, then this kind of porosity will form, that is called pinhole porosity. Then, due to molding material and methods, some defects are formed. First is drop and dirt. Suppose you're ramming the sand and some particles are dropped from the cop bags to the drag box, and that will form some projection on the surface. So that projection is called drop. And if some cavity is formed, that cavity will be known as dirt. Then this is also because of your improper ramming, scab and cuts. And cuts and washes are formed. Suppose there are some corners and your ramming was improper and your gating design was improper. So these corners are being eroded. So if something like that happened, then that defects are called as cuts or washes. Then metallurgical defects like hot tears or cracks. So due to non-uniform cooling, some internal stresses will be developed, and because of that, cracks will be formed. Those cracks are called as hot tears. Then again, due to mold shift or core shift, some defect will be formed. Suppose you wanted one cylindrical hole in your casting, so you added one core, but your core shifted little bit from the center, so there will be a defect that is called core shift. Suppose your shifted a little bit in your casting is not proper, then that is called mold shift. We are done with the theory. Now we will solve the questions. So you whatever the question is coming on your screen, you try to solve it first. Okay, this we already discussed in the last session, I guess. Then solve this question.
C.
Okay, anyone else?
Ma'am, this contraction allowed on the core boxes, ma'am, this contraction allowed on the pattern is understood, but what is that contraction allowed on the core boxes?
That see the contraction allowances provided on the pattern and core boxes, it is saying. So pattern also you will provide pattern, you know, no, why we provide allowance. For core
Yes,
boxes
ma'am, yes.
also, suppose you are making this kind of This is your core also. This is your core, right? So this will also have some solid contraction, right? So on your core also we provide some allowance. So that is what it is written as, allowance provided on core box. C was correct. I think people said C in the first. C is correct. C, what is they're telling, asking, firstly try to understand the question. What is it is asking that contraction allowance provided on the pattern and core box is compensated by. What are the three type of contraction? Liquid, solidification and solid, right? So we already know that liquid contraction and solidification contraction are compensated by riser,
Riser.
Riser.
Yes.
right? So to compensate solid contraction, what we do, we provide some allowance on the pattern or the core box as mentioned in the question. So C is the correct answer. So this question,
Then it causes the strength to go through a maximum.
okay,
Permeability to go through maxima.
yeah, B is correct. See what, uh, see again in question, what is it saying that increase in the water content in the molding sand. So while we were going with the theory of the molding sand, I have shown you two graphs, one for permeability, one for flowability. So, uh, increase in the if you'll increase the water content, your permeability will go through the maxima. Why? What is the permeability? Permeability is ability of the molding sand to allow the gas to escape. Okay, so if you add more water, this somehow this is your permeability, this is your percentage of water in increasing. So this was your graph, right? There is no relation of strength with the water content, right?
मैम है मैम मैम इसी तरीके का ग्राफ है पर बहुत आगे ही वो कट जाता है डिक्रीज करने लगता है
Huh, like it's not significant, right? Flowability and permeability will mainly caused by water content in the molding sand. That you should remember. For strength, we add some what we say additives and all. Okay, and we do ramming also for the strength. So your option B is correct. Solve this question.
ए
Correct. I think no doubts in this question, right? This we have already solved in last session. Solve this question.
Then C,
Okay. What else?
temperature A.
D.
ए
वन
C
ए
is the correct answer. Again, what is it asking in the question? Total shrinkage allowance means liquid, solidification, and solid. So what is say when there is no temperature, room temperature change, total shrinkage allowance on a pattern is independent of pouring temperature of the liquid metal. Okay, then solve this question.
Why is it?
See, this is your graph, right? This is your liquid shrinkage. Why? This is your pouring temperature, and this is your freezing temperature. So why this liquid shrinkage comes? Because of difference between pouring and freezing temperature, right? When it is saying that your room temperature is constant, okay. So only this area will not be affected. So that is why your option A is correct.
Well, is it because it is compensated by riser?
Compensated by.
Riser.
Yeah, that's the reason.
Okay. Solve this question.
Ma'am, D.
Yeah, correct. Any doubts?
No, ma'am.
Solve this question.
C.
Yeah, correct. Any doubts?
Yes, ma'am.
What is your doubt?
Ma'am, like I could not understand this question.
See, uniform ramming, it is asking that in a sand molding process, what will happen if you do uniform ramming? Okay, so ramming is not related with the gas porosity. Okay, then ramming is not related with the uniform flow of molten metal into the mold cavity. That will happen with your gating design. Then sand expansion time type of casting defect, that is also not related with the ramming. When you will provide uniform ramming of your sand mold, then it will improve your firstly mold strength, and then it will make your pattern dimensional, like your dimension will be stable. If your ramming was correct, there will be no dimension change. Suppose uh, suppose your sand was filled like that, and you didn't provide a uniform ramming. So somewhere there is more sand, somewhere there is less sand. So there will be some defect, dimensional defect in your end product. So that is why, to give strength to your molding sand and provide dimensional stability, we provide uniform ramming. Any doubts?
Yes, ma'am, understood.
Solve this question.
Option B.
Okay.
B, ma'am.
Yeah, B is correct. See what is happening in centrifugal cast during centrifugal casting. Uh, your very fine grain and high density products will be formed due to centrifugal action. Because due to centrifugal action, your molten metal will go like far from the center. See, whatever the high density particles will be there, that will go far from the center, right? In the centrifugal action. So that is why density will be higher, and fine grain structure will form because of fast cooling.
Ma'am, why won't it be D? Because
Ma'am,
segregation
D.
of
That is also correct. Slug secretion toward
इंटरनल होगा, आउटर्स के
outer
नहीं.
is written. It is not correct.
हाँ हाँ हाँ
Slug is what? Slug is impurity particle, na?
हाँ मैम.
So it will have less density.
हम्म.
So it will be near the center, not the outer.
हाँ हाँ got it मैम.
If it was inter, it was correct. Any doubt?
No मैम.
Okay, solve this question.
सी. मैम डी लग रहा है फिर.
Think.
सही है.
Ma'am, C option.
Yeah.
मैम
C
सी
is correct.
स्किन बॉब.
C is correct. Any doubt in this? Or that you all go through your notes and read about the
Ma'am, what's a button well? Like,
skim bob is where, like, after the sprue there will be skim bob,
ma'am,
right?
what's a button well? What's a
Sorry,
button? What do we mean by button well?
that I also don't know. Okay, apart from that, any doubt in this?
No मैम.
Okay, solve this question. Sorry?
मैम डी.
B, okay.
Aluminium.
डी मैम डी.
D,
यस प्लेन कार्बन स्टील.
okay, yeah, it just shrinkage allows. Okay, any doubt in this question?
Is it D? Isn't it total shrinkage? Oh,
Yeah, this total shrinkage allows. So it will be brass only. Okay. What is the maximum allowance we give for total shrinkage? To like for which material?
Ma'am, for plain carbon steel.
Steel.
Okay. What is the largest for the solidification?
Aluminium.
Okay. Largest for the uh, liquid and solid?
Ma'am, for it's brass for liquid.
Yeah. Okay. Solve this question.
A.
Polystyrene.
Yeah, polystyrene is correct. Polystyrene is just now we see na it was disposable. It can get evaporated. Wood sometimes we can use again. Rubber also for wax kind of pattern we can use again. Metal is permanent only. So polystyrene is the correct answer. Solve this question.
सी.
Option D.
C.
Yeah,
सी मैम.
C is correct. What is it asking? Shrinkage allowance on the pattern. When we give that for solid contraction, right? When solid contraction happens, after it turned into solid phase, and then from freezing it turned to room temperature. Like this was the graph. Here only solid allowances we provide. Now, so this is what, this is your freezing temperature. This is the room temperature. What it is written, metal drops from pouring to room temperature.
No, in the previous question before this, actually, total shrinkage is for, I think, steel only. No?
Okay, okay. That we solved, I think. So solve this question. Just now we discussed.
C. D, D, D.
D, ma'am. Yeah.
Yeah, D is correct. See, just now we discussed that whatever light impurities or slug will be there, that will be collected at the center of the casting. Option D is correct. Solve this question.
C.
Yeah, C is correct. There is no doubt in this, right? There will be one pouring basin, then one sprue will be there. After sprue, gate will be there. So, what is the purpose of primary purpose of sprue? Feed the molten metal from the pouring basin to gate. Solve this question.
Ma'am, B.
Okay.
Option C.
Yeah, C is correct. Why B? Okay, any doubt in this question?
Can you please explain this?
See, what is permeability? Ability, ability of a molding sand to flow the gas into that. So obviously, it is opposite of hardness. What is hardness? If your material is hard, gas will not be able to flow into that, right?
Okay, because we didn't have this method.
Okay. Solve this question. Sorry.
B.
B. B.
Yeah, B is correct. So this is how your misran looks like. This defect. Okay. Tell me the answer of this question. Just now we saw.
Investment.
Correct.
D.
Correct. Solve this question.
Tin.
Yeah, this also you should remember.
10.
Yeah, but
Low melting point metal.
yeah, low melting point metals are most suitable for hot chamber die casting. This one.
A.
Cold sheet.
Yeah, correct. Solve this question.
D.
D.
Correct. Okay, solve this question.
ए.
Okay, anyone else?
20, ma'am.
सॉरी मैम, ए नहीं है.
20, ma'am. B. B.
बी है.
So this is the most important formula for your casting. Every year they will ask some question on that. Okay, are you all able to solve this question? Or should I solve? Or some are solving now?
Ma'am, it will be 40.
No,
Uh,
that would be 20.
check again. The answer is 20 minutes. You might have done some mistakes here or there.
Heavier means density is more.
Sorry? Yeah, mass density. Let me solve that. See, from here you can write what is given in the question. Firstly, your M1 will be V1 into rho 1. Your M2 will be V2 into rho 2. So from here, your other material is 8 times heavier than the original casting. So what you know, mass is 8 times heavier. So from here only you can write your V2 will be 8 V1, right? Then T1 by 2 will be, suppose the size of your cube is A. So we can write it as,
So here the dimensions are not changing.
sorry,
So are we changing the dimensions here?
no, dimension will be same only. That's why I just, so your T2 will be, your T1 cube, then T2 by T1 into 2. So T2 will be 5 into plus 1. So it is coming 20 only. What is the problem? Okay, solve this question.
Wide range of solidification temperature.
Yeah, correct. So hot air is a defect that occurs due to solidification, wide range of solidification temperature in the casting.
मैम हॉट ईयर तो तब अगर होता है ना जब वो उसके साथ जो कॉम्पैक्टनेस मोल्ड में ज्यादा तगड़ी होती है.
Hot air is formed because of temperature gradient. Due to temperature gradient, some cracks will form, right? That is hot air.
Non-uniform cooling, ma'am.
Sorry?
Non-uniform cooling of the
Yeah. Whatever will give you a temperature gradient, that could be the answer for hot air. If thermal stresses will form, due to that cracks will form. That is what called as hot air. Okay, solve this question. Take your time, solve this question.
Option B.
Okay.
Option B, ma'am.
B.
Yeah, option B is correct. Any doubt in this?
No, no, ma'am.
Okay, solve this question.
Ma'am, A. Expanded polystyrene.
Yeah, just now we saw now. This.
Yes, ma'am.
What are the
We also,
pattern materials for full mold? That was
we,
polystyrene. This you should remember. This will come many times. This word polystyrene. This is the favorite word for gate examiners, and it is being used in full mold.
ma'am,
Thermocol is also there.
epoxy can also come.
Epoxy can
Ma'am,
also come.
thermocol from our
Thermocol is also come.
and plastic.
Sorry.
Plastic.
Yeah.
Why C was not the option? Because it was also kind of expandable.
You mean epoxy?
Yes, ma'am.
I think epoxy is not being used. Wait, let me check that. Yeah, epoxy is not a pattern material for full molding. The pattern materials for full molding is plastics, polyester, epoxy, uh, not any resin material. Plastics, polystyrene, foam, PVC, and thermocol only. None of the other pattern materials apart from expanded polystyrene is mentioned in the option. So that is why only option A is correct.
मैम वैक्स भी तो होगा क्योंकि इन्वेस्टमेंट कास्टिंग को लॉस्ट वैक्स प्रोसेस भी बोलते हैं.
हाँ, but this is full molding ना, not investment casting. Cavityless.
ओके ओके.
There are two. Investment is also evaporative. Okay. Okay. Solve this question.
सी.
Correct. Any doubt in that? Okay. Okay. Tell me the answer of this question.
मैम, ए और सी के बीच में थोड़ा कंफ्यूजन आ रहा है.
क्यों confusion आ रहा है? See, what you are not
Ma'am, I
asking
think
me
we
based
need
on.
to calculate the value of rho Cp by K.
No, no, you don't have to calculate that. What is there?
मैम
What are, yes.
मैम सी आंसर है.
Yeah, option C is correct. See, uh,
Ma'am,
conduct. Yeah.
yeah, ma'am, here we need to calculate the thermal diffusivity. So,
From conductivity also you can tell, right? Which one will cool faster if everything else is same? From just by seeing conductivity, because what we are this is a die casting, right? Three modes are there. So by just seeing conductivity, if the conductivity will higher, uh, the heat transfer will be higher. The copper's conductivity is the highest in these three materials. So copper will solidify the first, then aluminium, then steel. By that also you can say, right?
Even though
Yes,
specific
ma'am.
heats and
Yes.
densities are drastically different, this is the most important factor.
Uh, Density is also there, but see here, what is the tasking sequence of solidification? So with that also, it should be having more density. Like firstly, you should see only the conductivity. If diffusivity would be given, that would be the best. But if conductivity is given, that by that also you just can say, right. Uh,
ma'am, like we can calculate diffusivity to be on the safe side.
no, see the difference is a lot, right? Difference is almost twice. So there will from surely with the conductivity only you can say. You don't have to calculate diffusivity at all. Suppose it was aluminium and magnesium. Their melting temperature difference is only 10 degrees Celsius. Then maybe you are not sure about it. But here by seeing conductivity also only you can answer. Okay, C is the answer of this question. And this is only 1 mark question, and you will not get that much time to calculate diffusivity for three materials. So this is how you will answer. Okay, any doubts?
No, no, ma'am.
Solve this question.
Option C.
C.
Yeah, option C is correct.
See, ma'am. 8 minutes.
Everyone got option C. Do I
Yes,
need
ma'am.
to solve this?
Done now.
Okay. So before that we were solving 1 mark question. Now we are solving 2 marks questions. Solve this question.
Ma'am, for D it will be 1, and for A it will be 4.
Okay. Are you sure?
D was for 5, ma'am.
Ma'am, B would be 3, ma'am.
मैम रेन वाटर पाइप और ड्रेनेज पाइप
Yeah, I guess.
Ma'am, B would be 3, ma'am.
डी में
Cell molding would be cylinder block.
मैम डी का 5 होगा फिर
Yeah, correct.
Huh.
B5 is the most correct answer here. Rainwater pipe. Have you ever seen rainwater pipe?
यस मैम
Very, very big in the diameter. Hollow big pipe.
Cylindrical block is also
Cylindrical block. can also be. See,
Yeah.
what is the most appropriate for this application? Centrifugal casting, I have told na, big diameter hollow pipes are made by centrifugal casting.
Ma'am, C would be 2, ma'am. Machine tool bed.
Okay, C2. Anyone else?
यहाँ MC का 2 ही लग रहा है.
Yeah, C ka 2 is correct. A ka 4 is also correct. For B,
Cylinder
B,
block.
yeah.
Yes, no, it must be cylinder.
yeah, correct. Very nice. So this is your correct answer. 4, 3, 2, 5. Okay, read and read again the casting processes. One more theory notes I will share on my drive. You can read those also. Those also are very nice. All those questions.
Ma'am, for A it will be 2.
Correct.
B6 ma'am.
D3.
B6 correct. D3.
C5 ma'am.
D3 is also correct. Connecting rods are made by forging. We all know that, right? Why? Why it is made of forging?
Sustain fatigue
E4,
strength.
ma'am.
Sorry.
To sustain fatigue strength.
Yeah, it needs strength. Small grains. That's why we use forging. Someone
E4,
else?
ma'am.
C5.
C5.
E,
Yeah, C5.
E4, E4. Galvanized iron pipe. Extrusion process.
Whatever is written on your screen is correct till now. Whoever answered that. Now tell
I,
me for E and F.
I'm answering E,
F6.
ma'am.
Sorry?
I'm answering E. E would be 4. Galvanized iron
Yeah,
pipe.
correct, correct, correct. F is
F6.
in F is.
6.
Now think again.
1.
1.
Yeah, F is 1.
Tub and rollers. Hello.
मैम ए का 4 समझ नहीं आया, बाकी तो आ गए.
Extrusion you haven't read yet, but galvanized iron pipes are made by extrusion. Okay,
Okay.
okay. Do for this also. Okay, solve this question.
Option B.
Yes, ma'am.
C ma'am.
Option B.
Yeah, please.
1077.77.
Yes. So your solidification factor is given. Your diameter is given. Your formula is, so it will be P.97 into 10 power 6 multiplied by 4 by 3 pi r cube divided by 4 pi square, the whole square. When you will solve this, it will come as 1077.78 seconds. Any doubt in this?
No, ma'am.
Okay, so your option B is correct. Solve this question.
डी मैम।
Yeah, B is correct. Everyone got the answer? Or you are solving?
Yes, ma'am, got it.
So,
Ma'am,
solving, madam.
point 97 because pattern to that of casting.
Okay, let's solve. Shrinkage allowance is 1%, so it will be plus 1%. What we do, shrinkage allowance is positive, right? So it will be plus 1%. So firstly, we will find along the length. Along the length, 1%. So length is what? 200. So it will be 2 mm. So along the length, how much allowance you should provide? 2 mm. Then along the breadth, how much you should provide? It is 100. 1%, that is 1 mm. Then along the height, height is what? 10. It will be zero point 0.1 mm. Okay, so your volume of casting will be this much, and your volume of pattern will be the pattern that you finally made will be 200 plus 2, 100 plus 1, and 10 plus zero point 0.1. So this how much this will come? 2 into 10 to the power 5 mm cube. And when you will solve this, how much is it coming? 202 into 101
मैम
Ma'am,
6.1.
मैम
Yes.
इस क्वेश्चन में बात यह है कि जो ग्रे कास्ट आयरन है ना
हाँ.
वो एक्सपेंड करता है सोलिडिफिकेशन के बाद।
Okay, but it is not mentioned, right?
मैम ग्रे कास्ट आयरन तभी तो लिखा है, वो उसकी प्रॉपर्टी है मैम। तो सी मतलब तो ए आएगा मैम।
उधर उधर श्रिंकेज अलाउंस लिखा है।
अरे मतलब श्रिंकेज अलाउंस नेगेटिव है फिर और क्या।
No, if it explains pattern is larger, right?
अरे ये ग्रे कास्ट आयरन एक्सपेंड करता है सॉलिडिफिकेशन पे।
Yes, but they are asking pattern by customer because
Yeah.
pattern will be
no,
larger.
I
for
understood their doubt.
But ma'am, shrinkage allowance is given along with the length, ma'am.
No. Their doubt is that gray cast iron expands while cooling. So if that is true, option A will correct. That I have taken it as plus 1%. If that is correct,
Ma'am, for grey
option
cast
A is correct.
iron, for the casting of grey cast iron, we don't need riser. But if we talk about pattern allowance, yes, we provide a positive pattern allowance even for grey cast iron. It's just that for grey cast iron, we don't need riser because the graphite expands on formation.
Okay. Okay, that explained everyone's doubt, right?
मैम तो ए वाले को मतलब टिक करेंगे कौन सा।
No, option D will be correct.
ओके मैम।
How much this is coming? It is 2.0605 VC by VC will be 2.06 into 10 divided by 2 into 10 power 5. The option B is correct. Okay, next solve this question.
Ma'am, option D.
Yeah, option D is correct. I think this is a bit easier than before, right?
होलो स्टैचू इससे स्लस कास्टिंग से कैसे बन ओके ओके ठीक है ठीक है
It is mentioned in slush casting applications also. Okay.
व्हाट आर दीज डेंचर्स
Dentures, it is used in dental application. Dentures, you ever visited to a dentist that is used for to give some support to your teeth? Not sure that much. But if any kind of applications like that is coming, dental related, that is made of investment casting only. Always remember.
ओके
Ma'am, is that ma'am made of ceramic materials, ma'am, on dentures?
Yeah, it could be. It is mostly made of composites, but ceramics, I'm not sure. Okay. For this
मैम
question,
सी और मैम सी और डी ऑप्शन का वो समझ नहीं आया थोड़ा
CAA option, right? Okay,
मैम
C
सी
and D
एंड डी
का
को एक बार
applications नहीं समझ में आया. See, both are mentioned in the application of the castings, right? Just now we discussed. Both the applications are mentioned only.
ओके
For this question,
B.
yeah, B is correct. Any doubt in this question?
नो मैम
Okay, solve this question.
Option B.
correct. This is a big question only. Take your time and solve this question. Not that big. See, for truncating your formula is AH divided by AG, okay, to 2GHM. For bottom gate, your formula is OC is 2A divided by AG root 2G root HM minus under root HM minus H. Then what they are telling that your HM is H.
into HT.
Yeah, say so put this value and then find TB by TA. So when you will solve this, your TB by TA will be coming as 2. So your option B is correct. See, here automatically from here you can see this term will be 0, and when it is HM, so it will be root HM only. So only 2 will be extra. So from there only you can see that TB by TA will be 2. Any doubt in this? Uh, any doubt in this?
No, it's clear.
Okay. Okay, let's solve some interesting questions. Everyone is getting bored. Solve this question.
हाँ, 100 मैम.
Okay.
50 मैम.
50-50.
Anyone else?
मैम 100
50,
को
50 is correct. So, do you have any doubt in this question?
नो मैम.
Your Q is given as dot is given as 10 what is happening over here, you have to consider only this area to calculate your latent heat of fusion. Okay, I think guys are getting bored, so we'll solve all these questions in next session. There are around 20-30 questions left that we will solve. Or you want to solve for recent years? There are less questions only. Okay, we will solve in next session. Thank you.
Madam, please
Okay, ma'am. Thank you.
last question.
Yes, ma'am. The last question, can you please?
This one? This one?
No, no, the last question is solved. No, no.
You want to solve?
Latent heat question, madam.
Yes, ma'am. Latent heat.
I
This
have
one?
not understood, madam. Please, will you explain, madam?
Sure, sure. So, what is the latent heat of fusion? So, it is the amount of energy that must be supplied to a substrate to change its phase, like to trigger the change in this physical state, right? To convert it from liquid to solid or solid to liquid, right? So, where is it happening? Conversion, phase change in this region only, right? This is the solidification happening, right? So, heat removal Q is already given with the rate. The rate of heat removal is given as 10 kilowatt, right? So from here you can get the Q. How much time is taking for the solidification process to be happening? 20 minus 10, set 10 seconds, right? So from there you can calculate how much heat is dissipated in that time. Okay, like per second it is 10 kilojoule. So in 10 seconds, how much it will be that you can calculate, right? 10 cross 10. Then what is the mass that is given? Q is ml, right? Mass was given as 2 kg. So from there you can calculate where L is your latent heat of fusion. Now you got it?
Yes, madam.
Ma'am.
Now we have to take this region of fusion. That is connect your whole way to solve this question. One more way to solve this question, suppose you don't remember or you don't know the concept behind the question, you check the units. It doesn't work all the time, but sometimes it works. You have to get your answer in kilojoule per kg. Okay, don't use this method all the time, but sometimes you can do kilojoule per kg. What you have 10 kilojoule per second and you have 2 kg also. So here you can write first 10 kilojoule per second. If you divide it by 2, here 1 kg will come. Now you have to remove this second time thing. So that for that you should know how much time you should multiply this. So here from here you can see it is 10 seconds. So now whatever the answer will come will be kilojoule in kg. Okay.
Ma'am, I'm taking class on Saturday.
You have what?
So there was class on last Saturday.
I didn't get you the first part. Can you say again?
Uh, are you taking class on Saturday? I mean, there is a slot given in the site that there is class on Saturday.
No,
No,
Which
Saturday.
yeah,
Actually, Saturday, one more person is taking the class who took on Wednesday.
yeah. But he changed the topic.
The topic is on metrology, ma'am.
Yeah, he changed, I guess.
Yeah, he changed the topic to metrology. The class will be on this Saturday from 7.
okay, ma'am.
Which is Rakesh, right? Rakesh is taking class on Saturday, right?
Wednesday slot is shifted to Saturday, right?
No, no. He's doing extra class.
No, no.
Wednesday also he's doing, and Saturday also he'll do.
Which time, ma'am? Saturday and Wednesday?
Wednesday. It is mentioned on the.
On Wednesday, on Wednesday it is 7 to 8. Actually, in the schedule, it was mentioned another slot on December 7th.
Yeah.
So it was from 7 to 8.
Okay, Saturday also it's 7 to 8 extra.
Yeah, Saturday 7 to 8, and on Saturday there is one more class from 6 to 7.